Hello everyone, welcome to our channel Online Classroom. Today we are going to discuss the topic solution of system of linear equations. So let's start the topic and try to discuss the things one by one. So first question will arise, what is system of equations? Now basically system of equation can be split into two parts. First one is called linear system and another system is called nonlinear system. Now, what is basically linear system? Look, 2x plus 8y plus 4z equal to 5, minus x plus 5y plus 3z equal to minus 7, and 3x plus 7y minus 3z equal to 6. If I consider all these three equations, look, the powers of x, y, z, that means the variables, the powers are basically 1. If all the powers of the variables are 1, then this is called linear system. But what is non-linear? Look here, if I consider the first equation, this one, this is basically 2x square plus 8y square plus 4z square equal to 5. So the powers basically 2 in all the cases, or it may be 3 or 4, whatever. So if powers of the variables, these are basically greater than 1, then it is called nonlinear system. So that is the first classification of system of equations. Now we move to the topic system of linear equation classification. Basically, this particular system of linear equation can be split into two parts. First one is called homogeneous system. Another one is called non-homogeneous system. Okay. Now, what is homogeneous system? Now, if I focus on the matrix portion, Ax equal to 0, this particular portion is called the homogeneous system. Okay. Basically, A is called the coefficient matrix, S is the corresponding variable matrix, 0 that is the null matrix. Now, what is non-homogeneous? If I consider Ax equal to B, this particular form, then it is called non-homogeneous equations. Look, this is a set of equation or system of equation. Here we can observe that 1, 2 up to m number of equations are there, okay, and n number of unknowns like x1, x2 up to xn. So n number of unknowns are there. And if I consider the coefficient matrix of this total system, it will be A. A is nothing but the coefficient like A11, A12, A13 and so on, A1n. So that is the first row. Similarly, second row, third row and up to m row. Okay, so this is the coefficient matrix. Now what is x? X is nothing but the variables. Here we observe that x1, x2 up to xn, these are the variables. So we plot the corresponding variables in a single column. So that is the corresponding x vector. Now what is b? B basically constants. Constant means b1, b2, b3 up to bn. So if I consider these things, then this is called b. And what is 0? 0 is nothing but the null matrix. So if I consider Ax equal to 0, this particular system, it is called homogeneous. And if I consider Ax equal to B, this system, it is called non-homogeneous system. Okay. Now we are focusing on non-homogeneous system classification. Look, if I solve any kind of non-homogeneous system, first character of the corresponding solution is inconsistency and consistency. So two characters are present in this case. Now in case of inconsistency, we have no solution. Okay, but in case of consistency, we can split it into two parts, unique solution and infinite solution. Now question will arise, what is the unique solution, infinite solution and what is no solution? Okay. Suppose if a system of equation is given, first we will calculate the coefficient matrix. This is the coefficient matrix and it will be denoted by the symbol A. And this particular zone, that is A, B, this is called basically augmented matrix. Look, in this particular category, we have the coefficient matrix and just add another column. It is nothing but the constants B1, B2 up to Bn. So this is totally, it is called augmented matrix. Now, if I consider the rank of A, and rank of this augmented matrix, we have to check this particular flowchart. Suppose rank of A and rank of the corresponding augmented matrix, these are same. If both the ranks are same, it is called consistent system. And if I focus on the first step, that is basically rank of A bar, that means the augmented matrix, and number of unknown. Okay, N denotes the number of unknown. If these three are equal, then we get unique type solution. But if rank of A, rank of augmented matrix, these two are equal, but the corresponding number of unknown, this is not same with the rank value, then it is called infinite type solution. Consistent system, but infinite type solution. But third case may arise that rank of A and rank of the augmented matrix, these are basically not same. In that particular case, it will be treated as inconsistent system, and in this particular category we will conclude it as no solution. So that is the main classification. That means whenever we will focus on system of linear equation, if we know the characters, the corresponding flowchart, we can easily identify the characters like unique solution, infinite, and no solution. So let us discuss one of the example and try to classify the corresponding steps. Look, this is a system of linear equation. Three equations are given: x plus y plus z equal to 1, 2x plus y plus 3z equal to 2, 3x plus 2y plus 3z equal to 5. So three equations are given. So whenever we will try to judge the character of the solution, first we will need to construct the coefficient matrix, and that is the coefficient matrix. And if I consider it as A, it is nothing but 1 1 1. Look, first equation 1 1 1, then 2 1 2, third equation 3 2 3. So this is the coefficient matrix of this system. Now if I focus on the augmented matrix, first write the coefficient matrix, and after that just add the fourth column, that is 1 2 5. This is the corresponding fourth column as a constant. So this is the augmented matrix. Okay. Now we will perform some operations on augmented matrix such that we can find out the rank. Okay. So this is the augmented matrix. Look, leading element is 1. So obviously our target is to create echelon form of this corresponding augmented matrix such that we can easily judge the rank value. And that's why using 1, we will try to create 0 in this position and in this position. So our operations will be R2 minus 2R1 and R3 minus 3R1. So if we perform these two operations, then we get this particular matrix. And we can observe that in this matrix, these particular positions are 0, but rest of the positions will be changed. Okay. Now, next target is to create 0 in this position using minus 1. Okay. So obviously, if we just subtract these two rows, then we can create 0 here, and that's why we will perform this operation R3 minus R2, and we observe that this is the matrix. Now look, this is a echelon matrix. Okay, row reduced echelon form, and we observe that two non-zero rows are there, this one, and also this one. So three non-zero rows are there actually. So the rank of the corresponding matrix becomes 3. But if we consider only this portion, only the coefficient matrix portion, the rank will be 2, because we have only first non-zero and this is another non-zero row. Okay, third one is 0. So obviously the rank of coefficient matrix, it is 2, but if I take it as a whole, the rank of augmented matrix, it is 3. Okay. So what is the result? We get rank of A equal to 2, whereas we get rank of A equal augmented matrix equal to 3. So these are unequal. So we can say that this is a inconsistent system. And if I focus on the flowchart, we know that inconsistent system means ultimately we can't get any kind of solution. So final answer will be no solution. Okay. So if you know the flowchart, using that flowchart, you can easily tackle any kind of linear equation, system of linear equation, and you can justify or classify the nature of the solution. Okay. Now in the next video we will discuss some other problems on linear system of linear equation, and we also discuss some categories like unique, infinite, and also the no solution cases elaborately. So stay tuned with us.